Hello everyone, this is Siddharth here, 14CS143, and I'm going to explain you how to write a simple C++ program for a predictive parser. So, which is a so this is a C++ to parse a given string using non-recursive predictive parser for a given grammar. So the grammar will be inserted, and for that particular grammar, the recursive parser will work, and for that we have to write a C++ program. So the simple description of this is a recursive descent is a top-down parsing technique that constructs a parse tree from the top, and the input is read from left to right. It uses procedures for every terminal and non-terminal entity. So this particular non-recursive predictive parser simply works from the top. So it will start the evaluation from the top, and the basic functioning of this parser is it evaluates from the input from the leftmost part to the right. So it starts from the left to the right. So it's a simple error parser. So I'll show you the program. So 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 as you can see over here, we first all the header files have been declared, and then for writing this particular program, we have given certain constants. So for giving the constants, we have simply define the size, none, eos, num, keyword, id, and max. So then we have declared the certain variables, which are character variables, the lexemes, the buffer, the last character, the less entry, tokens, token value, which is declared as none. The done, a look ahead, and this particular program, we've simply what we are going to use, we are going to use structures. So the structures are user-defined data types which can be created. So first of all, a character pointer has been created to the lex pointers, then a token, and the other part of this is a token, and then another structure called as entry with the keywords, with the array of keywords has been created which have particular values. So which has keywords if, else, for, int, float, double, char, struct, return, and these are the keywords. Now, so for the basic functioning of this is we have defined in the main function certain code of like function calls. So these function calls are for the user-defined user-defined functions. So one of them is an error message which receives a pointer pointer argument, and what does it do is it returns the error message as a string which comes as an exit. So next is a lookup, which finds the look ahead for the parsing. So for finding look ahead of the parsing, we take a for loop and we find the next particular lex pointer variable and store it and return that particular lex variable's index value, which is written by this particular function. Next is the insert function. So this is and the parameters over here, the token which is passed, and then the which passes an argument, and the S array which stores up all the particular variables, the entries. So if the last entry is max, then the error message is that the symbol table is full, or else if it is less than or greater than max, greater than or equal to max, then we say regimes and array is also full. So let me come to the main program, what it is doing. So this particular which is the Lexa program, which receives all the lexemes. What does it do? It takes so for finding for all the values, we just simply take while true, and once it gets false, it will be terminated. So what we're going to, we'll use we'll get a character, we'll store it in t, and if the particular character is a space or it's a tab, uh, will do nothing else. If it is a if that particular variable is a new line, so what we are going to do is we are going to add we increment the line number pointer, that which shows that we are going to the next line. Okay, the next, if the particular t which is entered the character is a digit, then if it is a digit, what we're going to do is we'll ask the user to enter a token value, so that for that particular thing a token value will be inserted. As if it is an alphabet, now when it comes to alphabet, there are certain things we have to do. We have to find out the error. So the error message will be displayed as compiler error match. Now for finding though we have also declared a user-defined function known as match. What it does is particular user-defined function, what it is doing is it compares the look ahead. Now, if the look ahead is the look ahead variable is what the user has entered, then we'll save the look ahead as the Alexa value which is received, or else we'll simply display the error message. Now, for displaying the arithmetic operation, now if it is an operator plus, minus, a star, or division, we'll simply display that it's an arithmetic operators. And if it is a number, we'll display it's a number. And if it's an identifier, as we declare all the identifiers, we'll display it from the symbol table that it's an identifier. And if it is token, then the particular token's value will be declared. Now, next what we are going to do is we have certain for displaying all the particular output, we are given a switch case. Now this particular switch case will receive the look ahead look ahead variable which we have declared above. And what we're going to do, if the look ahead is a number ID, or it's an opening break, where that particular, then the particular matched IDs and the display function will call display function for that particular number, or if it is a token, or if it is an identifier, that particular display function will count with that value along with the its particular token value. And if it is default, then the error message will be displayed. Let's come to the main function. So what the main function is doing is, in the main function we'll ask the user to we'll just simply print that program for recursive descent parser, enter the expression. We'll ask the user to enter the expression, and then we'll call the other function, the parser function, which is the main function, which is calling all the other values. So I'll compile this. Okay, now I'll run this. So if A plus B plus C, so the particular identifier is A, B, and then the operator C, operator plus, which is found, and again the identifier C, which is found as well. So thank you for watching. Have a nice day.